Introduction to polynomial functions and graphs. The zeros of a polynomial. Well, what does that mean? The number k may also be a complex number, is said to be a zero of the polynomial function. This is your polynomial function. If f of that number is equal to 0. This is also expressed by saying that k is a root or a solution of the equation f of x equals 0. In other words, if you have a function, let's just say this one is our function right here. This is your function. If you were to take this number k, which in this case is 3, and plug it into this function, then it would be true. Or if you were to put everything on one side and set it equal to 0, then it would make that equal to 0. That means that that number would be a root or a solution of the function. A polynomial equation in one variable is an equation that can be written in this form, where all the a's are constants, assuming that the first one is not equal to 0. We say that such an equation is of degree n. This just means you write your polynomial in descending order. So all of your exponents are decreasing as you read left to right. And if that's the case, then your leading exponent, the highest exponent, is the degree of that function or of that equation. Verify that the given values of x solve the corresponding polynomial equations. Well, to do that, all we have to do is plug them in. So for this first one, we'll have 5 times 3 squared minus 3 cubed equals 12 plus 2 times 3. Well, this would give us what? 5 times 9 minus 27 equals 12 plus 6. So 45 minus 27 is equal to 18. Is 45 minus 27 equal to 18? And it is. So 3 is a solution for this equation. So how about b? We would take the 4 plus 2i and plug it into this equation. So then we would have 4 plus 2i all squared is equal to 8 times 4 plus 2i minus 20. 4 plus 2i squared, that's going to be 16 plus 16i plus 4i squared equals, distribute your 8, so 32 plus 16i minus 20. Now if we were to subtract 16i from both sides, these will both be 0. So on the left we have 16 plus 4 and I squared is negative 1. Then we have 32 minus 20, which is 12. This would be 16 minus 4 equals 12. And that's also true. So yes, 4 plus 2i is a solution or does solve this equation. So now let's try C. So for C, we want to know if 0 will solve this equation. So we will have 0 over 1 minus I is equal to 5 times 0 squared. Well, that's going to be 0 equals 0. So yes, it looks like this one also solves that equation. The next thing that we want to talk about is the behavior of the graph as x approaches infinity or negative infinity. So if you remember the general shapes of these graphs, your x squared function is your quadratic function, which makes this parabola. And I want you to notice, as x is getting bigger, as x is going this way, what is y doing? Y is also getting bigger. So for this one, you would say, as x approaches infinity, or as x gets bigger, y also approaches infinity, or y gets bigger. So what happens when x gets smaller? That means x approaches negative infinity. What does your y do? Well, as x goes in the negative direction, y still goes in the positive direction. So y still approaches positive infinity. Okay, so look at your negative x to the 5th function. Remember when you graph it, it looks something like this. As x gets bigger, what's y doing? Y is getting smaller. So for the second example, you would say, as x approaches infinity, y approaches negative infinity. Y is getting smaller. So what's happening when x gets smaller? As x approaches negative infinity, y approaches, it's getting bigger. So it's approaching positive infinity. Okay, look at this last example. This is your negative 2x to the 4th function. As x is getting bigger, what is y doing? Y is getting smaller. So as x approaches infinity, y approaches negative infinity. And as x approaches negative infinity, what does y do? As x is getting smaller, y is also getting smaller. So y is also approaching negative infinity. You can determine all of those things on the last slide by learning this, the leading coefficient test. I think that it's easier just to figure out what the graph looks like based on some other things that we're going to learn in this section, and then you'll know what the behavior is as x approaches positive and negative infinity. Okay, so this is what all of this means. If you have an even degreed polynomial, that means your polynomial begins with x squared, x to the 4th, x to the 6th, x to the 8th, so your exponent is even. If your leading coefficient is positive, your even degreed function will look like this. Hopefully by now this is something that you know. So as x gets bigger, that's what this one is. As x gets bigger, y, or f of x, gets bigger. As x gets smaller, y still gets bigger. That's what that means right there. If your leading coefficient is negative, then your graph is going to reflect over the x-axis. And in this case, as x is getting smaller, y is getting smaller. As x is getting bigger, y is still getting smaller. That's how you would read this graph, or this table. Now look at this one. If your leading exponent is odd, then your graph is, and I should throw this in there, and your leading coefficient is positive, your graph looks like this. So as x is getting bigger, y is getting bigger. As x is getting smaller, y is getting smaller. And that's what this stuff in this box means. So how about this one? This time your leading coefficient is negative, which means your graph looks like this. So as x gets bigger, y gets smaller. That's the second line right here. And as x gets smaller, y gets bigger. That's the first line. So really, if you can determine the shape of your graph based on the highest exponent, it's a lot easier to figure out what's happening as x approaches positive and negative infinity. At this point, the value of writing a polynomial function in factored form will be very apparent. If we are able to factor a given polynomial f into a product of linear factors, every linear factor with real coefficients will correspond to an x-intercept of the graph of f, To see why this is true, consider the polynomial function. What all of this means is if you were to set each one of these factors equal to 0, 3x minus 5 equals 0, x plus 2 equals 0, and 2x minus 6 equals 0, then what you will find will be the x-intercepts. These are the things that make the function equal to 0. So add 5 to both sides and divide by 3. Subtract 2 from both sides, add 6 to both sides, and divide by 2. So your x-intercepts correspond to these zeros. They are 5/3 0, -2 0, and 3 0. Since this, if you were to multiply it all out, you would have this 3x times this x times this 2x. This is actually a third degree polynomial because your leading coefficient would be 6x cubed. So since this is a cubed function, or a cubic function, we know that our graph will look something like this. Of course, some crazy stuff could go on in the middle, but the general shape is like this one. What this tells us is the graph will actually either touch or cross at each of these. Can we find the y-intercept of that same function? How do we find the y-intercept again? To find the y-intercept, you must let x equal 0. So to do that first step, y will be equal to 3 times 0 minus 5 times 0 plus 2 times 2 times 0 minus 6. So we get -5 times 2 times -6, which is -5 times 2 is -10. -10 times -6 is a positive 60. So your y-intercept is the point 0, 60. So let's see if we can graph it. Remember, each of these represents your x-intercepts. That's what we found on the previous slide. And we also know that the general shape looks something like this. So what else we know is it's going to come up. It's going to come up and touch this point, -2. It's actually going to go across at -2. It's going to go up somewhere, all the way up to 60 maybe. It's going to come back down, and it's going to go through the point 5/3 0. It's going to go down, it'll come back up, and it'll go through the point 3 0. So the graph will probably look something similar to this one. I just happen to have that graph for us right here. So you can see this is the point 0, 60. It crosses at -2. It crosses at 5/3, which is 1 2/3, and it crosses again at 3 0. This is your graph of that polynomial function.